Hello friends, today we are discussing the protection and privilege levels for the subject microprocessor, a part 4 with the call gates or in a previous lectures we will see that how the call gates works and how it will access the control and all these things. With this call gate, four privilege levels are used to check the validity of the control transfer via the call gate. The CPL, RPL of the selectors are used to specify the call gate. DPL of the gate descriptor. A DPL of the descriptor of the target segment. Only the call instruction can use a gates to the transfer to the smaller privilege levels. CPL stands for the current privilege levels. The RPL stands for the restricted privilege levels. The RPL of the selectors are used to specify the call gates. DPL descriptor privilege levels of the gate are descriptors. A DPL of the descriptors of the target segments, which only the call instruction can use the gates to transfer the smaller privilege levels. The call instructions are used to transfer the privilege levels from one level to the another layer. There are three levels: CPL, DPL, and the RPL. For the jump instructions, the privilege rules are like this: the maximum of the CPL current privilege level, the restriction privilege levels, is less than the gate of the descriptor privilege levels. Means whatever the maximum value of the CPL or the descriptor, which must be less than the DPL value. For the jump instruction, the, the target segment DPL is equal to CPL. Okay, whatever the level is there, so numerical value is there. For the call instructions, the rules are maximum of the CPL or a RPL, that is the current privilege level, or a restricted privilege levels, which is less than a DPL value. The target segment DPL is less than or CPL. In that case, the call instructions are executed, whereas the jump instructions are executed when a CPL maximum value of the CPL current privilege levels and a restricted privilege levels are less than equals to the DPL value. So in that case, the jump instructions are executed. The call instructions are executed when a maximum of the CPL and the RPL value is less than equals to the DPL value. The target segment DPL is less than the CPL. Here, the target segment DPL is equal to CPL in case of the jump, whereas in case of the call instruction, a DPL value is less than equals to the CPL. So then only the call instruction is executed. The privilege check via the call gates. Yes, we have seen in a previous figures also that a 16-bit selector, visible selectors is used here. A CPL current privilege level is given to the CPU check by the privilege check by the CPU. A target selector RPL, which is also given to the privilege check by the CPU, and a gate selector, a DPL, a descriptor privilege level. Okay, DPL value is also given to the privilege check by the CPU. If the executable segment descriptor, in which if the base value, limit value, and the descriptor privilege value is there, if a DPL value there is match, then the current privilege level, then a privilege level will be selected for the. In the multitasking, we'll see that how the multitasking will be carried out. A number of IO map base is shown in a figure. Registers are shown here: EDI, ESI, ESP, ESP, EBX. These are the registers. Flag registers are their instruction pointer. EIP, external instruction pointer. CR3 control registers are PDR, and okay, all these things are shown here. Okay, TSS descriptor. A TSS descriptor is for the 32-bit TSS. A base is from 24 to the 32-bit. G value, granularity value is there. A limit which is of the 16 to 19-bit. P bit is there, a descriptor privilege level is there, a type, whether it is a type 0, type 1, uh, and a base value is there. A base value from the 16 to the 23 bits is there, a base and a limit at the 0 bit, which is given here, a task register, a task state segment, TSS, as in the previous. Here, the TSS task test segment is shown here. A TSS task register in which the task state segment is there, which a limit value of the uh, task register is given to the task state segment. A selector value is of the task register is given to the global GDTR, global descriptor table. Okay, so in which a task state segment descriptor table is also there. So depending on these values, a task state segment select the task register, which allows the task a task register instruction. The instruction which are used in a task register are a load task register. It loads the visible portion of the task register. It loads the visible portion with the information from the TSS descriptor selected by the operands. LTR is a privilege instruction. It may be executed only when a CPL is 0. Current privilege level is 0. A loads LTR means a load task register is a privilege instruction. It may be executed only when a current privilege level is 0. LTR loads the invisible portion with the information from the TSS descriptor selected by the operand. LTR load task register is generally used during the system initialization to give an initial value to the task register. Therefore, the content of the TR are changed, but the task switch operation STR store task register. The store task registers the visible portion of the task register in the general register or the memory word. STR is not a privilege. LTR load task registers. LTR is generally used during the system initialization to give an initial value to the task register. Therefore, to store the visible portion of the task register, it loads the invisible portion with the information from the TSS descriptor selected by the operand. LTR loads the visible portion of the task register, and the STR, that is the stores task register. It stores the visible portion of the task register in the general purpose register or a memory words. STR is not a privilege, whereas LTR is a privilege. Task get descriptor, it is not uh, selectors which is of the 15 to 32 bit, whereas having a P bit and a descriptor privilege level bits are there. A task gate descriptor is there. A task gate descriptor, first of all, to access a DPL and a P bit to access the values. A local descriptor table as shown in a figure. A task gate is there which goes to access a GDT global descriptor table, whereas the IDT interrupt descriptor table also access the global descriptor table. To have a privilege levels, they both access the GDT through the LDTs, a task test statement TSS. All these GDT access the TSS. So if I interrupt IDT and I LDT access the GDT and the GDT access the TSS to set a privilege levels. A task gate descriptor condition to access the gate. Maximum of the selectors RPL and the CPL of the procedure is numerically less than or equal to the DPL of the descriptor. When a task gate is used, the DPL of the target DSS descriptor is not used for privilege checking. When a DPL is used, a TSS descriptors are not used for the privilege checking. Several target ends that select the single TSS descriptor, the need to provide selection access to the task, the need for an interrupt or a execution to cause a task switch. When a task gate is used, a DPL of the target task TSS descriptor is not used for privilege checking. Several task gates that select the single TSS descriptor, maximum of the selector's RPL and a CPL of the procedure is numerically less than that or equal to the DPL of the descriptor. The, the need for the interrupt and execution to cause the task fetch. Thank you friends for watching the video.